Okay, so up to this point, we've looked at factoring binomials and trinomials, and today we're going to look at factoring uh, and solving radical equations. Okay, so the first thing we're going to do is look at restrictions on values for the variables in a radical expression. Okay, so when we do this, we're mainly going to look at the restrictions, and that restriction will give us the domain for our radical expressions. Now, the first thing that you need to know is what a restriction is. And so a restriction for a radical expression are the values that make your denominator equal to 0. All right, so just like we were doing in the last section, we're finding out the numbers which our values or which our expressions could actually be. So the first thing we want to do with this question, consider the radical expression square root of x. Alright, so the first thing we need to do is on the grid, sketch the graph of y equals square root of x. Okay, so we're going to type this into our calculators. So, square root of x, and we're going to graph this. Alright, so if you notice what this graph is looking like, we're starting at the origin at 0 and 0, and then we're extending to the x-axis. Alright, so that's what I'm going to do over here. And we're extending in this direction. So the first thing we need to do is state the domain of the graph of y equals x. So remember, what the domain is telling you on a graph are the set of values which are actually the set of x values, which will tell you what is going to define this line on your graph. So if we look at this, our domain of x needs to be greater than or equal to 0. Right? And even if you were to type this into your calculator, it has to be greater than or equal to 0 because those are also real numbers. Right? Like if I have the square root of 0 and I calculate that, I'm just going to get 0. But if I have anything less than 0, so -1 for example, it's a non-real number or a non-real answer, and so that won't be defined on our graph. So for what values of x is the radical expression square root of x defined? So the value of x that our radical expression square root of x is defined is going to be given to us in our answer of our domain. And so this is going to be the same answer of our domain. X is greater than or equal to 0. Now if you remember in grade 10 we wrote this in a different way. We write it like this: x such that the values of x are greater than or equal to 0, and also that x is an element of real numbers. Alright, so that's how we would have talked about it last year in grade 10. And that's the same way we can describe it here. But it's perfectly acceptable just to say that x must be greater than or equal to 0. So consider the radical expression square root of x minus 2. State the domain of the graph of y equals x minus 2. Alright, so let's do this again. We'll plug this into our calculators. So square root of x minus 2. Oh, that didn't pan out. Square root of x minus 2. Let me graph this. Alright, so notice that we're starting at our positive 2 here. And remember, we're trying to solve this as an expression in which we have a denominator set to 0. Alright? And so let's sketch what this will look like on our graph. We're going to start at positive 2, and we're extending in this direction up our x-axis. Okay? Now the next thing we need to do is state the domain of the graph of y equals square root of x minus 2. Now, just like this graph, we said that our x had to be greater than or equal to 0. Or sorry, the above graph here. X had to be greater than or equal to 0. Down here, we're starting at positive 2, which tells us that in order to define the line of this graph, all our values need to be greater than or equal to positive 2. Okay? So x needs to be greater than or equal to positive 2. And so for the radical expression, which we just solved, state the restrictions on x. So it's going to be the exact same as our domain. The restrictions on x are going to be x must be greater than or equal to positive 2. Now we want to know if, how do we explain the restrictions algebraically? Right, just like you were doing in the lessons before, if we set our equation equal to 0, and so if we have x minus 2 must be greater than or equal to 0, we can solve this equation, and we can do so algebraically. Okay? Now, when we're doing this, we want to get rid of our radical sign here. All right, and so the only way to do that is to square both sides. So if I square 0, I'm just going to be left with 0, and if I square this, I'll get rid of that. So that means I'll be left with x minus 2 is greater than or equal to 0. And now what we can do is we can just bring, just like we would do in any algebraic equation, if we were dealing with an equal sign here, we are just going to add 2 to the opposite side. So x will be greater than or equal to, add 2 to both sides, and we'll be left with positive 2 minus 2. X is greater than or equal to 2. All right, so algebraically it works out. Now let's look at number 2 here. Consider the radical expression 3 minus 2x. Okay, so on the grid, sketch the graph of square root of 3 minus 2x. So square root of 3 minus 2x. Oh, okay, so now we're still starting in our positive x-axis, but now we're going to the left. All right, and if we look where that is, that's at about 1.5. Okay, so we're starting at 1.5, and then we're going up into our negative x-axis. Okay, so let's see what we got to do for this question. Okay, we sketched it. Now we need to state the restrictions on the variable. So remember, with these ones, our restrictions were, with our above questions, our restrictions were 0 and positive 2, and that's where we were starting our graph. Now we're starting our graph at negative, or at positive 1/2. So our restrictions, and then we're going the opposite way. X must be equal to or less than, since we're going the opposite way, negative, or positive, 1.5. Or we could also write this as 3/2. Okay, now we need to determine these restrictions algebraically. Alright, so just like I did in the above equation, I'm going to set this equal to 0. 3 minus 2x is greater than or equal to 0. And so I'm going to get rid of this radical sign, and this is just going to become 3 minus 2x is greater than or equal to 0. Now I need to bring this 3 to the other side, so negative 2x is greater than or equal to negative 3. Now I need to divide both sides by negative 2, so I can isolate this x. So negative 2, or sorry, I got rid of that. Let me move up here. Dividing both sides by negative 2 will leave me with x on this side is greater than or equal to negative 3 divided by negative 2. And so what I'm left with is x is greater than or equal to negative 3/2. I'll switch this around. Positive 3/2. Alright, and so there you have it, solving it algebraically. Now let's move on to the next section. Radical equations. So just like we were doing last time, we want to find out what our restrictions are going to be for our for our equations. All right, so which values can we insert to our radical equations which will make it true? All right, and so essentially what will leave us with a real number. Okay, so algebraically determine any restrictions on values for the variables in these radical equations. Okay, so first of all, I'm not going to go through and do all of them. I'll just do the ones that you may have the most difficulties with. Okay, so the ones I'm going to focus on are going to be A, B, and then I will also show you how to do D. Okay, so 4x plus 1 minus 8. Again, when we're approaching these sorts of questions, what we want to do is we can ignore this 8 because we want to set it equal to 0. Right? Because we're just worried about the radical expression here. So 4x plus 1 is greater than or equal to 0. Now, solving this algebraically, I'm going to be left with, I'm going to have to get this 1 to the other side, and so I'll be left with 4x is greater than or equal to negative 1. And then if I get rid of this this 4 over here, I have to divide this expression by 4, and I'll be left with x is greater than or equal to negative 1 over 4. All right? And so one way you could check to see if this is a value that actually makes sense is you can put it into your calculator. So 4, negative 0.25, or negative 1/4, plus 1 is equal to 0. So it checks out. All right, so square root of 2 minus 5x, and then minus 7 is equal to 0. Again, we're not really worried about this negative 7 on the outside. All we want to know is what our restrictions are for the variable in our radical expressions, or radical equations. And so we're just looking for that restriction there. And so in order to solve that, we just want to set this equal to 0. 2 minus 5x is greater than or equal to 0. And in order to solve for x, I'm going to bring this negative to the other side. So I'll add 2 to both sides, which will leave me with positive 2. And then I need to solve for x. X is going to be greater than or equal to negative 2 over 5, since I had to divide by negative 5. All right, so let's see what this looks like. 2, root 2 minus 5, negative 2. Oh, you know what I did? So I made a mistake here, because this should be a negative, which will leave me with a positive answer. And so that will be negative 2 divided by negative 5. And so remember, if we were dividing by another negative over here, we had to, and if we're switching this sign to give us a positive and positive, since a negative and a negative will be a positive, then that's going to flip our inequality sign. And so this means that x is going to be greater than, or it's going to be less than or equal to 2/5 rather than negative 2 over 5. Okay, so what we'll be left with is x is greater than, or is less than or equal to positive 2 over 5. Okay, so let's see if this works in our radical expression, which we began with. So root 2 minus 5 times 2/5 gives us 0. Now let's see what would have happened if we didn't change that. 2 minus 5, and if I hadn't pointed out my mistake there, gives us 2, not 0. We wanted to finish with 0, and so this would not have been a correct answer if we left it at negative 2 divided by 5. Alright, so now what we have here is we have two radical expressions. Right, so now if we have two radical expressions, then we need to solve for both of them. And so I'm going to try to write pretty small here just so I have enough room. But if I'm solving for both of these radical expressions, then this first one is going to be x plus 2 is greater than or equal to 0. And then I need to solve for x. x must be greater than or equal to -2. Since I have a positive 2, I subtracted 2 from both sides, and I'm left with -2. And now over here I have 3 minus x, which means that 3 minus x must be greater than or equal to 0. And I'm going to have my negative x over here, since I'm going to subtract 3 from this side and this side, is greater than or equal to -3. And I'm going to divide by a negative x, or sorry, -1, which means if I'm dividing this by -1, notice that my inequality sign is going to switch around. Okay? And I'll be left with positive 3. And so now what happens is I have two values of x that could potentially satisfy this equation. X is greater than or equal to -2, and x is less than or equal to 3. So what this is telling me is that if I draw this on a number line, I would have 3 right here, and I would have -2 down here. And I'm being told that x is greater than or equal to -2, so that's telling me that x must be up here somewhere. But I'm also told that x is less than or equal to 3, which means that I would be going in this direction. Okay? And so in this case, my x value can be both. Alright, so what all this means is that x is greater than or equal to -2, but less than or equal to 3. So it has to be in between of these 2 points. Alright, so my x value is going to fall somewhere in here. Alright, it could be anywhere between these 2 points. Okay, so I'm going to try to make this a shorter video, which means I'm going to try to hustle through these questions a little bit. Again, if you need to pause anywhere, if you need to try some more of these questions, then I really encourage you to do so. And if you're having difficulties, make sure you ask for help in class. But let's move on to this next section, and that's solving radical equations graphically. So consider the radical equation x plus 1 is equal to 4. So first of all, state the values for x for which the radical equation is defined. Right? And so if we were to solve this algebraically, by now you should be able to look at these and just know that if you have x plus 1 is greater than or equal to 0, then you're just going to move over this 1, and so x plus 1 is greater than or equal to 0 would become x is greater than or equal to -1. Okay, so those are going to be our restrictions. Now, explain how to use a graphing calculator to find the solution to the equation by using the intersect feature of the calculator. Now, this is something that the last time you would have used this would have been in our first unit on sequences and series. Okay, so the first thing you need to do is graph in your y1 x plus 1 and the square root of x plus 1. And the second thing you need to do is graph in the y2 4. Okay, so what we want to do is find out where these two lines at y1 and 4 are going to intersect. Okay? So I have in this part of my equation I'll have x plus 1, and down here I'm just going to have 4. Right? So don't forget the square root, and don't forget to close your brackets here. And then when you graph this, it will look something like this. Okay, so the next thing we need to do is find the x x coordinate. All right, we want to find out where these two are going to intersect. And if you look, it looks like they're intersecting somewhere off of our graph, somewhere over here. If I were to extend my window settings, here we're told. So one thing you can do is you can just zoom out and then intersect, because from here, if you were to intersect, second function trace is what I did. Second function trace, and then I'm going to choose this category here. Press enter and enter. It's not going to give me the answer because it says no sign changing, and that's because my points are actually off my graph. Okay, and so I'm just going to clear that, go back to my graph, and I have to adjust my window settings. But here they actually give you the window settings. And so if you are told that it's -3, 20, and 1, like this, then what this means is that your x min is going to be -3, your x max will be 20, and the scale, this is just going to be 1 increment between each point. And then for your y-axis down here, it's going to be -5, 5, and 1. All right? And so from here we can graph it, and hopefully it'll show us exactly where that point is going to intersect. And yeah, there it is. It's where y is equal to 4, and we'll find out what that point is by doing our trace function. So second function trace, option 5. And so you have to enter the point on your first curve. These are just guess, but we're told that it intersects at x is equal to 15. Okay, so at y is equal to 4 and x is equal to 15. So state the solution to the equation down here. X is equal to 15. And now let's see if we were to actually graph this. It's starting at x is equal to -1, and then we are extending up to 15 and 4, so right about here, and that's where our lines are going to intersect. So that's what our graph actually looked like. So right here is going to be at 15, and this is at, well, it should have been at 4. So this line itself, the equation of this line is y is equal to x plus 1. Okay, now what we need to do is verify the solution is correct, and we need to do so algebraically. And so to verify something, we talk about the left side and the right side need to equal. LS is left side, RS is right side. Okay, so actually this is going to be a quiz question. So your quiz question will be, what does LS equal and what does RS equal? LS is equal to left side, RS is equal to right side. There's your answer. Okay, so let's see, LS is equal to, and that's the left side of the equation, is equal to x plus 1, and our right side of our equation is equal to 4. And so if we were to insert the value of x into our left side of our equation, that's going to be 15 plus 1 is equal to 4. Now 15 plus 1 is 16. The square root of 16 is equal to 4. So for this equation, LS is equal to RS. Therefore, our solution is verified. Okay, so hopefully you know how to solve these algebraically. Next thing we're going to do is look more at solving radical equations algebraically. Okay, so complete the following steps to solve the following radical equation and verify the solution. Okay, so if I have x plus 1 is equal to 4, actually this is the one we just did, so yeah, actually I'll do this quickly. So what they did here is this was the equation that they are using. X plus 1 is equal to 4. And the first thing they did was they squared both sides. Alright, and so if you were to square x plus 1, or square root of x plus 1 squared, you're just going to be left with x plus 1. And if you square this side, 4 squared, you'll be left with 16. Because what you have to do to one side, you do to the other, right? And so if I were to subtract 1 from this side, I need to subtract 1 from this side, and that's going to be left with x is equal to 15. And then you need to verify the solution, and so your left side is equal to 15 plus 1 square root of that, and that's equal to 16, which equals 4, and that equals the right side of your solution, of your equation. And so yeah, it checks out again. Good. Okay, so I decided to do this question after all. Okay, so solving radical equations algebraically, this, you can kind of look at this as part 2. But if I wanted to solve this, this part of my equation, to complete the following steps to determine the roots of the radical equation 3 plus the square root of x minus 1 is equal to x, and verify the solution. Okay, so this is the equation we're working with. The first thing we need to do is isolate the radical term. Okay, and so to isolate the radical term, what we did was we bring the 3 over to this side over here. So if you have 3 plus, notice that this 3 is outside of my radical expression, or outside my radical term, and so I need to subtract 3 from both sides. That will give you the square root of x minus 1 is equal to x minus 3. Okay, then we need to square both sides to get rid of my radical sign. Okay, so squaring both sides will get rid of that radical sign. And then solve the equation. So we're left with x minus 1. And if we square x minus 3, notice that you'll be left with a perfect square. Right? You'll be left with x squared minus 6x, because remember you go your two inside terms, multiply them together. So 3 times x will give you 3x, and then multiply it by 2 will give you 6x, plus 9, because negative 3 and negative 3 is going to be positive 9. Now what we need to do is bring this 1, well, we need to bring all this to the other side and set it equal to 0. Okay, so if I bring this negative 1 to the other side, I'll have to add 1 to both sides, which will give me x is equal to x squared minus 6x plus 10, since I'm adding 1 to both of these sides. The next thing I need to do is bring this x over here to set this equal to 0. So I'm going to subtract x, which gives me 0, x squared minus 7x plus 10, and I subtracted x from this side as well. That gave me the 7x. Now we need to factor this. So this step down here is what you were doing in, I think, lesson number 5. Right, when we set this equal to 0. Now, what I need to do is find out what my values of x can be in this problem. And so I need to multiply, in this case, remember, I need to multiply 2 numbers to give me positive 10, and add 2 numbers to give me negative 7. Okay, so they need to have a product of positive 10 and a sum of negative 7. And so, you thinking what I'm thinking? Negative 2 and negative 5, there's going to be our numbers that we need to use. So x minus 2 and x minus 5. And so that tells us that x is equal to positive 2. If we were to solve this algebraically, x would be equal to positive 2, and x would be equal to positive 5 as well. Now, let's verify this solution. Remember, to verify solution, our left side needs to equal our right side. So LS must equal RS. Left side must equal right side. So let's look at this first part of our equation, x minus 2. Or, sorry, x is equal to 2. And let's plug this into our original equation, which was 3 plus 2 minus 1. Or, sorry, it'll be 3 plus the square root of x minus 1. Okay, so that's the left side of our equation. And there should be a plus there. 3 plus 2 minus 1, because our original equation was x minus 1. So that's going to be 3 plus 2 minus 1 is 1, which is square root of 1, or 3 plus 1, and that equals 4. Now let's see the right side of our equation. So our right side of the equation is just x. Right? And so if the left side gets equal to 4, our right side was just x. And if we just plug in 2, 4 does not equal 2. So that means that our left side does not equal our right side. when x is equal to 2. Now let's see when x is equal to 5. Okay, so 2, this first one does not work. X did not equal 2. So let's see if 5 works. Now let's plug it into our equation. And last time that was pretty scrappy, so let me try this. X minus 1 is equal to x. So for the left side, this is our left side. 3 plus 5 minus 1 needs to be equal to 5. Okay, so 3 plus the root of 4 needs to equal 5. Let's see if this is the case. 3 plus square root of 4, square root of 4 is 2, so 3 plus 2 equals 5, and 5 does equal 5, therefore that checks out because left side does equal right side. So that means that 5 is our only solution. Okay, so what in a question like this, when you have two possible solutions to your equation, only one of them is going to actually work out. Okay, and so when this occurs, this is known as having an extraneous root, which means that there can be more than one answer, but only one of those answers will give you the correct solution. And so that, in this case, it was 5. That gave us the correct solution here. Okay, and so I'm trying not to make this video too long. And so I just want you to remember these steps down here. And so this is on the next page, 268. But use these following steps to solve radical expressions algebraically. Step 1, isolate the radical term. So if it's something like x plus 3 plus 7 is equal to x minus 4. If it's something like this, you have to bring this 7 to the other side. So then it would be x, the square root of x plus 3 is equal to x minus 4 plus 7, right? Or x plus 3. So if there are two radical terms, isolate the more complex term. Then you need to square both sides of the equation to get rid of that radical sign. And then if the resulting equation contains a radical term, then you need to repeat these first two steps and then square that radical term, or isolate the radical term again, and then square both sides again. Then the last thing you need to do is verify all answers, because the squaring in step 2 may result in extraneous roots. That is all.